All right, so get this. Someone sent us their notes prepping for a presentation all about quantum computing.
Quantum computing. Oh, wow.
Yeah, and let me tell you, even for someone like me who's been following this topic, it's still pretty mind-blowing. So, are you ready to have your mind bent a little?
Well, quantum mechanics usually does that, but I'm ready.
Cool.
Let's do it.
Okay, so the big question is, what is quantum computing? I hear it is more than faster computers.
Yes, it's way more than that. Think about it this way. The bits in your laptop are like a light switch, on or off, 1 or 0. Now, a qubit, that's the building block of a quantum computer. It can be on or off or both at the same time. It's called superposition. And that is just the tip of the iceberg.
Okay, so a qubit is doing a balancing act. How does that actually translate to more computing power?
So imagine you're searching a maze. A regular computer tries each path one by one. A quantum computer can explore all paths simultaneously.
Whoa, really?
So it's not just speed. It's like having a superpower for some complex issues.
Okay, these notes mention something about drug discovery. How does that fit in?
Well, think about simulating how a new drug interacts with a virus, like at the atomic level. A quantum computer could map out all the possible interactions almost instantly
Nice.
and help us design more effective treatments way faster.
So it's not just theoretical, it's got real world potential already.
Exactly.
And this is where things get really interesting. The notes also talk about unbreakable encryption. Like, how does that work?
Yeah. So quantum computers have the potential to break the encryption we use today to protect, our online data. However, they can also be used to create new types of theoretically unbreakable encryptions.
Interesting. So it's like a double-edged sword.
Yeah, kinda. And it's not just encryption. We're talking about tackling problems like climate modeling that are just too massive for even supercomputers today.
So the possibilities are pretty mind-blowing.
Yeah, haha, I feel that mind bent now.
But these notes also mention some major hurdles. Building these quantum computers is no easy feat, is it?
It is not. Remember those qubits doing the superposition dance? They're incredibly picky. Even the slightest disturbance can knock them out of alignment. We're talking temperatures colder than outer space just to keep them stable. So let's get to the big ones. We'll get to the fact that
Colder than outer space? That's intense, and it sounds expensive to operate.
I'm guessing intense is an understatement. It takes massive energy to maintain those low temperatures and shield the qubits from interference, such as vibrations and light, you name it. It's a delicate and costly operation.
So it's like building a computer out of snowflakes in a sauna?
That's funny, yeah, pretty much.
No wonder it's taking time. All right, back to the main topic. How do these qubits actually work their magic? We touched on superposition, but the notes mention something called entanglement too.
Entanglement. This is where things get truly bizarre. Imagine two coins flipped at the same time. They always land on the same side, even if one's in New York and the other's in Paris.
No way. That sounds like something we would see in a sci-fi movie.
That's entanglement, two qubits linked in a way that defies our everyday understanding of physics.
Spooky action at a distance. So, these unique properties allow quantum computers to perform many calculations in parallel, making them exponentially more powerful for specific tasks, right?
Correct.
So, entanglement and superposition. Those are the two keys to quantum computing's power.
Yep, the dynamic duo. Entanglement allows for this mind-boggling connection between qubits and superposition, allowing each qubit to explore multiple possibilities at once. Combined, unlike anything we've seen before, they create this massively parallel processing power.
Amazing. Okay, I'm starting to see how this all fits together. But hold on. Isn't that a huge security risk if quantum computers are so good at breaking codes? The notes mention quantum's resistant encryption, but what does that even mean? And
Quantum-resistant encryption is like building a fortress specifically designed to withstand a quantum siege. It's a new type of cryptography that uses complex mathematical problems that even a quantum computer would struggle to crack.
so it's like a cat and mouse game, but at least we're not completely defenseless, right? What about the broader implications, though? I mean, if quantum computing can potentially crack our current security measures, that's a big deal.
Absolutely. The potential risks to privacy and security are something we need to take very seriously. It's like discovering a powerful new tool. We need to learn how to use it responsibly and ensure it doesn't fall into the wrong hands. It's a bit like the early days of the internet. No one could have predicted all the ways it would change our lives. There is good and evil. Quantum computing has the same potential for disruption, and we must be prepared for it.
Okay, that's food for thought. We've covered the what and the why of quantum computing, but now I'm curious about the how. I get the basic idea of qubits and entanglement, but how do scientists actually build these things? It sounds incredibly complex.
It's like building a computer out of individual atoms and then convincing them to behave in a completely counterintuitive way. One of the most promising approaches involves using something called superconducting circuits.
Superconducting circuits, lay it on me. What are we talking about here?
Imagine an electrical circuit, but with zero resistance. That's what happens when certain materials are cooled down to extremely low temperatures. They become superconductors. These superconducting circuits can be used to create and control qubits.
Okay, so we're harnessing the power of super chilled circuits to manipulate these quirky qubits. But why the extreme cold just to keep the qubits from throwing a tantrum?
It's more than that. At those ultra-low temperatures, the qubits become incredibly sensitive, which allows us to control and manipulate their quantum states with incredible precision. But it also makes them incredibly fragile.
It's a trade-off. Extreme cold for extreme sensitivity and control. But I'm guessing this makes building a quantum computer a logistical nightmare.
It's a massive undertaking. Think about it. You're not just building a computer, but creating an entire environment to support it. We're talking about specialized refrigerators to maintain those near absolute zero temperatures and shield them to block out any stray electromagnetic interference. And add in incredibly precise control systems to manipulate the qubits.
It sounds like building a high-tech fortress for these quantum snowflakes. Yeah, I'm back to my snowflake analogy. Now I understand why it's such a cutting-edge field. Okay, so I've got the hardware side, the qubits, the superconducting circuits, the ultra-low temperatures. But what about the software? How do you program a quantum computer?
That's another frontier. Traditional programming languages just don't cut it in the quantum world. We need entirely new algorithms and approaches to harness the power of superposition and entanglement. Think of it like writing sheet music for an orchestra, where each instrument is a qubit and the melody is the computation.
It's not just about learning a new programming language. It's about learning a whole new way of thinking about computation. I'm going to have to go back to school.
Exactly. It's a paradigm shift. And it's attracting brilliant minds from all over the world. Physicists, mathematicians, and computer scientists all collaborate to unlock the potential of quantum programming.
It sounds like the ultimate brain teaser, and maybe a bit of a job security guarantee for anyone who can crack the code. Speaking of cracking codes, earlier we talked about how quantum computing could be used to break encryption. But the notes also mention some more positive applications. What else can these quantum machines do?
Oh, the possibilities are vast. One area where quantum computing is expected to have a major impact is material science.
Material science. So, figuring out better ways to build stuff?
Essentially, yes. Imagine being able to design materials at the atomic level, tailoring their properties for specific applications.
I'm imagining.
Quantum computers could help us create lighter, stronger, more durable materials for everything from airplanes to bridges to medical implants.
So we're talking next level engineering powered by quantum mechanics. What else is on the horizon?
Another promising area is quantum computers, which could revolutionize the way we design and develop new medicines, allowing us to simulate the interactions between molecules with incredible accuracy.
Wow, that's amazing. So instead of spending years and millions of dollars developing a new drug, we could use a quantum computer to simulate its effectiveness and potential side effects in a matter of days or even hours.
Exactly. And that's just scratching the surface. Quantum computing could also revolutionize finance, logistics, and artificial intelligence. So,
Okay, I'm officially blown away. It seems like quantum computing is poised to touch every aspect of our lives. But with all this potential, there must also be challenges, right? Aside from the sheer complexity of building these machines, what other hurdles do we need to overcome?
building a quantum literate workforce is one of the biggest challenges. We need more people who understand not just the science behind quantum computing, but also how to program and apply these machines to real world problems.
So it's not just about the scientists and engineers who build the hardware. It's about creating an entire ecosystem of quantum experts.
Precisely. We need to invest in education and training programs, and we need to inspire the next generation of quantum programmers, engineers, and entrepreneurs.
It's like we're building a whole new industry from scratch. And we need to make sure we have the talent pipeline to support it. But talent isn't the only hurdle, right? We also need to think about the ethical implications of this technology.
Absolutely. With any powerful technology, there's the potential for misuse. We need to have open and honest conversations about the risks and benefits of quantum computing. We must also develop ethical guidelines to ensure this technology is used responsibly.
So it's not just about the science and engineering, it's also about the social and ethical considerations. We must ensure that quantum computing benefits humanity, not just a select few.
I couldn't agree more. The future of quantum computing is a shared responsibility, and it's up to all of us to shape it in a way that benefits society.
All right, so we've covered a lot of ground here, like the nuts and bolts of quantum computing, the qubits, entanglement, and all that. But there are a couple of things in these notes that really jumped out at me, stuff that sounds straight out of science fiction.
Oh yeah, I think I know what you're talking about. We're getting into the realm of speculation here. But that's where things get really interesting.
Exactly. First up is the quantum internet. What is this thing, and how is it different from the internet we use every day?
Well, it's faster. And not just for those cat videos. But the quantum internet is about way more than just speed. Imagine a network where information is not only transmitted instantly, but also with absolute security. That's the potential of a quantum internet.
Okay, so we're talking unhackable communication. How does that work?
Remember entanglement? That spooky action at a distance where two qubits are linked, no matter how far apart they are? Well, a quantum internet would use entangled qubits to transmit information. Any attempt to intercept the communication would instantly change the state of the entangled qubits, alerting both the sender and the receiver that something's fishy. So for instance, could say I am an intern qubit.
Wow, that is amazing. So it's like having a built-in alarm system that goes off if anyone tries to peek at your data.
Exactly.
That's incredible. But what about the practical applications beyond super secure communication? What else could a quantum internet enable?
One exciting possibility is distributed quantum computing. Imagine multiple quantum computers around the world, all linked together via a quantum network. They could work together as one giant, super powerful machine, tackling problems that would be, impossible for a single quantum computer to solve.
So it's not just about connecting people, it's about connecting quantum computers themselves to create a sort of global quantum brain.
Right. I know it sounds a little scary, and we're really getting into sci-fi territory, but how realistic is all of this when can I expect to browse the quantum web?
A full-fledged quantum internet is still a way off. However, researchers are making steady progress. We're already starting to see small-scale quantum networks emerge, and it's only a matter of time before these networks grow in size and complexity.
So maybe not tomorrow, but it's definitely on the horizon. What about the implications for artificial intelligence? The notes mention quantum computing, like giving AI a major boost. How would that work?
Quantum computers are incredibly good at handling the complex calculations that underpin many AI algorithms. They could potentially analyze massive data sets, identify patterns, and make predictions with an accuracy and speed that's unimaginable with classical computers.
So we're talking AI that can learn and adapt at warp speed, making decisions and solving problems that are currently beyond our reach.
Exactly. Quantum-enhanced AI could revolutionize fields like medicine, finance, and even art, leading to breakthroughs in drug discovery, financial modeling, and creative expression.
But I can't help but think back to what we discussed earlier, the potential for misuse. If quantum computing can boost AI to such a degree, don't we run the risk of creating something that's beyond our control?
That's a valid concern, and we need to address it head on. As we develop these powerful new technologies, we need to prioritize ethical considerations, ensuring that AI remains aligned with human values and goals. It's not just about making AI more powerful, it's about making sure it's beneficial for humanity.
So it's a delicate balancing act, pushing the boundaries of what's possible while also ensuring that we're using these technologies responsibly. It sounds like there's a lot of work to be done, both on the technical and the ethical fronts.
Absolutely. Quantum computing is a journey, not a destination. And it's a journey that requires collaboration, innovation, and a deep understanding of both the potential and the risks.
Well, after this deep discussion, I can confidently say that quantum computing is one of the most exciting and potentially transformative fields out there. It's pushing the boundaries of our understanding of the universe and opening up possibilities that were once considered science fiction.
It's a reminder that we're living in an age of incredible scientific discovery and that the future holds possibilities beyond our wildest dreams.
And to all our listeners out there, we hope this Technically You podcast has given you a better understanding of the potential of quantum computing and why it is so important in the world we live in. So keep learning, stay curious, and buckle up for the quantum ride. It's going to be a wild one.
And who knows, maybe one of you listening will be the one to unlock the next big breakthrough in this fascinating field.
See you in the quantum future.